Hi, I'm Jim Huntzinger of Lean Frontiers, and welcome to this session on lean process development. Kind of before we get going here, I want to set up a little bit of context around what I'm going to be talking about today. So I'm going to talk about some level of a granular level, but also not non-granular level. For this reason is you may have a background in manufacturing. I'm going to talk kind of from a manufacturing background, but your background may be manufacturing, but it could be in machining, fabrication, or you may be involved in the service industry or healthcare industry, or maybe in assembly or other things. So that's why I'm not going to get too granular, because certain things depend on what you're in. But also too, mainly because what I'm really talking about is a different way of thinking, a different pattern of behavior. So for example, for those of you familiar with Kaizen or the Kaizen workshops, even though I'm not going to talk about those much, I might mention briefly, not really that much at all. I'm talking about the process development. The Kaizen workshop techniques that you may know, they were all part of this behind the stories that I'm going to tell. They were certainly utilized, but again, I'm not going to talk about those directly, because those were really originally set up for when processes were kind of already there, kind of predetermined, but they weren't designed for flow. They were really usually designed for batch. And you use those techniques to go in and change a batch designed process or processes and try to turn it into flow. So what I'm going to talk about today is more of a deeper level, at a manufacturing engineering level, kind of how do you right design a process or processes to begin with? So how do you design it for flow from the beginning? So in that context, I'm going to talk about that. So with that, we'll get started. Okay, I'm actually an engineer by education and career. I'm actually a manufacturing engineer and operations manager by my career, at least before I got to Lean Frontiers. And when I came out of school, I took a position with a company called Seiki, which is a Toyota Group company, but not because of Lean or Toyota Production System. Actually, at the time, I knew nothing about that. I took it because it was a plant startup. Actually, my part of the plant wasn't even built yet, so I saw it as a great opportunity to go through a plant startup, in manufacturing, machining and assembly. So with that, I actually eventually got sent to Japan to get training on the Toyota Production System and also our products we'd be making, the machine tools, the processes, and so forth. So I went through that process. So I was there several years and then took another position a few years later at Briggs & Stratton. And the reason I did that is I wanted to get involved in that upfront process development, because at Aisin, the Japanese engineers had done the process development, and myself and my colleagues had kind of picked up the baton for the ramp up of production. So literally, when I went to Briggs & Stratton on my second day there, it dawned on me that the rest of the industrial world did not function or operate like this place that I had just left, Aisin and Toyota. But that was actually the reason they hired me, because I was supposed to know something about that. And really, I'm going to start from there on how that process went and start off talking about our main parameter, design parameter that we used. We worked to design to one-piece flow. So our most fundamental design parameter from a process development standpoint was one-piece flow. Now, sometimes people say true north, one by one, flow, and so forth. Back then, we would just say one-piece flow. We didn't have all these other terms. But literally, everything I'm going to talk about kind of rolling through this presentation, that is the underlying design parameter that we worked towards and drove everything we did in going through that process. So let me walk through a few assumptions that we had. And I would say you need to have from this process development from a manufacturing engineering standpoint. One assumption would be, and you'll notice I have in there, it says assumptions for a lean process and product development. So I'll reference product development here because really these things should function tandemly, even though there's some separation from it, but should function tandemly. So for example, the first one is, marketing customer requirements. You really should know a lot about that, even though that really probably that more resides in the product development or the product engineering guys, and also, of course, marketing, because that's what you're talking about. You need to have some level of understanding of about what the customer requirements are. What are the features the customers are looking for? You need to have some grasp of what that is. So discussions with obviously product engineering and even marketing are important for you to do your role in this process development arena. I'm not going to spend a lot of time on these, but I want to point them out because they are important. Also, also making the assumption that lean product development techniques are being utilized. Hopefully they are from your product engineering folks. Things like set-based lambda, trade-off curves, the whole gamut. And it's a whole nother actually event that goes on because there's so much in that arena. But hopefully some of those things are going on as well. Also, a certain level of experience in implementing flow and designing machines and processes with right design in mind. Now, that's ideal. I know in some circumstances you aren't necessarily going to have a lot of experiences, which is why you're seeing some of this. And I'll talk about some ways when I first started out, we didn't have a lot of experience, but what I did with my colleagues and what we did together to compensate for that. I'll touch on that as we go through this as well. And also another assumption is the role of technology and the trade-off. So you should not let technology drive you, although it's not a problem to use technology when you're developing processes, but it depends on your need and your needs and the effectiveness of it. And what it really is, the technology should be subservient to the flow and subservient to the processes you're trying to do. You don't want technology for the sake of technology. Hey, I'm an engineer. I can relate to things in technology that are really neat, but it really should be things that enhance what that primary design parameter is around flow or one-piece flow, what you need, not technical needs you might need if you're cutting chips or other things like that, but really should always be subservient. So a lot of times people say lean is anti-technology. It's not, but the technology should be supporting what you're trying to do with it. Okay, so to dive in these, I guess these little learning loops, feedback loops I have here is looking at the first one, or right design. And we're going to talk about this one more as we kind of roll forward as well. But by right design, and that particular one is really the physical process that you're building, the equipment, the machines, and it may not necessarily be equipment, especially if you're in the service industry or things like that, but the real kind of tangible processes that you're going to do in design. And really how this design, this equipment, these machines, if they are linked to your overall flow. So that's very critical to do that, particularly obviously for the process engineer, the manufacturing engineer. Another one is, the second one is actually the one there on the right, where it says specifications, is I call it function versus cost. So what this is really about is your product specifications or tolerancing versus process capacity or capability. How those tolerances impact what you're doing. And this is where we get into particularly a lot of interaction with your product development, your product engineering people as well. And then the third one, which is kind of the center one, is the how and why. It's really a reconciliation process. So process within process, a reconciliation process between these other two loops, between what you're doing with the product engineers and that product development and the design. And what we like to say is actually the part print. In this case, my background, the part print was really a contract for the whole thing and battling that out. And then also too, what you're doing from the machine tool or the equipment standpoint and how to link those. How do you reconcile those processes as well? And that's important. And so the next slide, as we go to it, I want to show this and talk about this a little bit. So I said at the beginning, what this is really in the context of is about the patterns of behavior and the thinking behind it. And that's critical. And the more you do this, the more confidence you build up and ability to go through this process development as well. But the reason I want to touch with this, this particular slide and this diagram is this diagram kind of comes out of Mike Rother's Toyota Kata book, for those that have read it. And when I read that book when it came out, I think 2009, 2010, I completely related to this book because essentially what it went through and talked about, and I think this diagram really encapsulates, is what my colleagues and I had been living, in at that time when I read it, in my past life. That's where we were, this unclear territory between, again, we didn't have this terminology, but between this current condition where we're at and the target condition where we get to. That's where we lived through this whole process. Now, we practice these things, and actually I even have a, you probably can't see it in there, but the 5-question coaching card here where it walks through these things. What is the target condition? What is the actual condition? And the questions that you reflect on when you take up those steps on the back of the card. What did you expect? What actually happened? And so forth. And what obstacles were in your way and so forth. We were living this. Again, not in this codified formal manner, but all these questions we were going through on a daily, weekly, monthly, project level basis. I mean, and from all standpoints, from little tiny sub-projects within the project to the larger projects that we were going through, which is why I was able to relate to that book so much. Nearly every aspect of the project, and even all the sub-projects within the project that size, we were utilizing that. So in a way, we lived in this unclear territory. So to focus in again on the manufacturing engineering aspect a little bit, I say, with the manufacturing engineer, there's kind of a separation and a connection with it too. So, and I like to use a sports analogy. So if you look at a good, strong sports team that has that aspect to it, the strength of the team is really through the strength of the individual players. So the individual players need to be good in their position, know their position, execute well at it, but they also need to know, so that's that separate part. But they also need to know how that works in conjunction with the rest of the team, with the rest of the functionality. And that's that connection part. So we had to do that with the product engineers, with the shop floor people. We really needed to know how to do that. And from this standpoint, that's where, part of the kata comes in. If you're a kata person, this question comes up all the time. What do you think? Well, that's what we do with our colleagues a lot of times. We'd go, hey, I'm working on something. Again, since none of us really had a extensive experience, this is how we compensate for it. I'd go to one of my colleagues and I'd go, hey, Bob, I've been working on this. Can you take a little bit and come out to the shop floor? I want to show you something, and I want to ask you some questions. Because I wanted to verify if what I'm doing, I'm thinking through it right, I'm looking at every parameter. And he'd come out there and he would question me, I would question him. That's back really to these embedded kata questions that we would be doing that we did on a regular basis. I might pull one of the supervisors or a setup person or an operator and start going through that process with them as well, is asking them questions. What do they think? And have them ask me, give me feedback. And now I can't express how valuable that was, this aspect, to making the success of developing the process. Also, too, from a manufacturing engineering standpoint, on the leading edge. So on the leading edge, by on the leading edge, again, I'm not saying technology. I'm not saying it excludes technology, but I'm not really saying technology. We'll talk about this a little bit more later. But looking at things differently, how do you use existing things, and how do you use them completely different? In a way, on the leading edge, even though your technology and even some of your machines don't necessarily change drastically. And I'll give some examples for that a little bit later. And some of this too on the leading edge is, again, as in this role in process development, you're really kind of an integrator. Like I said, the end customer, marketing, product development over here, and also you have the shop floor, your operators, your setup, quality, supervisors that you're trying to connect all this to. You're really in this integrating role to try to connect these. So ultimately, these things develop a system that functions very well from the operator all the way to the end customer. That's a lot of, in this role, process development, your responsibility. You're really an integrators to connect the final market to the shop floor. And then the final one, of course, I've mentioned them along, is the supervisors and operators out there. Just how important they are. That goes back to the Kaizen workshop. Ideally, a lot of that functionality we do in the Kaizen workshops, ideally, that's being done at the operator, supervisor level, the fine-tuning, the daily problem solving. Not that you may not get involved with that, but their role. and the learning they get and making adjustments and improvements. But your job also too, say you deliver this nice system out there and it works, great. But you still should maintain a feedback loop, communicating with them. What are they doing? What are they improving? What are they learning? So you know, so you understand, so you have a rapport with them. And also you can take their learning and integrate it into the next generation of a machine or process or line or whatever it might be. That continual feedback loop should be ongoing. And also too, I think I may touch this on a little bit later. That's where the TWI, Training Within Industries, and I think if you, when you watch the session by Oscar Roche, he's going to talk about some of this, but where TWI, or since that Plan, Do, Check, Act at that level becomes so important for the operators and supervisors, but also important for you to understand that. You may not necessarily be proficient at it, but you should understand that and know what's going on with it. So again, just reiterating in this slide, just really how that whole CATA, and really, I really want to say, and even TWI, that whole type of questioning functionality becomes so important in all those loops. The right designing, the specification and interface with marketing and product development, product engineers, and then again, the reconciling between all those. That questioning activity should be integral to all that. So I'll dive in each one of these loops, I think, a little bit more as we go through this. So in this case, again, like I said, that loop one, the right designing, kind of the responsibility of a manufacturing engineer or process engineer, is how do we design equipment? So this ties back to that one-piece flow and how important of a design parameter that was. So that was important to the way we designed it and the way we were trying to design a particular machine, a line, or the overall system for flow. And everywhere we could, where could we implement one-piece flow? And again, there's a lot of overlap here because it is important that the operators and supervisors are part of that, because you're trying to deliver them a system that they can operate and at a stable level. Again, that's where TWI plays a role in that, but also obviously good machine design, fixture design, and so forth. So you need to deliver a system to them that's going to work for them and their needs. Again, where standard work becomes so important in that part. And again, the aspect from a design standpoint or system design it has up there. So that's where the one-piece flow. So are we designing not only our machine tools, but our fixturing, our tooling, our line layout, material handling? I mean, everything should be designed for one-piece flow. And I'll, again, talk about that a little bit, some examples. So that's really critical to keep that. And that's why that one-piece flow design parameter was so important to literally everything we did. So again, this one I'm going to tell a little bit of story. So this other loop, this function versus cost or specifications, the product specifications, tolerancing. So in this loop, as we were working with the product engineers, ultimately the story I had on my process with this was I like to call it like a pickup basketball game with your buddies. Or basically, if your bone doesn't get broke, it ain't a foul. And that's the way we work together. Now, luckily, we had a great rapport with our product engineers, but when we get in our meetings, they were brutal. I mean, we were brutal on each other, but it was really asking all questions again, asking and demanding each other to explain, why do you want this tolerance? Why is this important to do that? Because we would question everything, question volumes, question the testing they were doing, questioning tolerancing. They would be questioning us. So why do you need this tolerancing? I can get that tolerance, but can you get me another $500,000 to get a machine that's capable? So for example, there was a call out on a part I was working on, a geometric tolerance. And it was very tight. So I questioned them on that. And they kind of said, well, that's what's always been on our drawings for that particular component. And I had spent time going out to the shop to ask the foreman of the department, because he'd been there for 30 plus years, you know, is this something that they hold? And basically what I found out from him is they had never hold that from a capability standpoint as long as he had been there. And they'll come out and do capability studies to find out they're not capable, but ultimately they need to get product out, so you keep going there. But what it told me, the next question was to the product engineers was, well, have we ever had any feedback from the market that this is a problem, that we have failures? And ultimately the answer was no, there wasn't any failures out there in the market, which told me that we didn't necessarily need this type of tolerance. We've never produced it for 30 plus years. There was not a market failure out there, certainly due to that. So we need to reconsider it. But there was a lot of cycles. This was over several months to go through this process to try to get that tolerance changed. Because of course they were demanding me back for me to justify my reasons for wanting to change it. And you've heard of the 5 whys. I always called this thing, in this case, was an example of the 500 or maybe 5,000 whys. Because I mean, I was asking why over and over again, digging in all types of things. But with this relationship we had, we went through all kinds of processes with the product engineers through, like I said, through a pretty brutal but very amicable process for months as we went through this and developed all the components and the final product. But the thing it did show me is, because we didn't have anything necessarily a codified process, we had chosen to do this on our own between the manufacturing engineers and the product engineers, and we met at least twice a week for months, even if we didn't have anything in particular, just to make sure our communication was there. And it made me also understand as you get a little more formal process with something like that, how much of an impact you can make. Because we made a tremendous impact on the manufacturability of the product, on the quality of the product that we'd ultimately get out to the customer we'd supply to and the end customer, and also from a cost reduction standpoint. So the next or the third loop is, again, that reconciliation process on taking all those things that we had done with the product engineers, the specification, or I like to say the contract of the part prints, and how do we get it to where we can manufacture that and deliver a good system that the operators and supervisors can be comfortable and confident that they're going to produce the part and not have headaches through that, and do it effectively through one-piece flow, as we talked about. Again, that integrator role that we had. And there's a lot of details behind that. I'm not going into that because that's going to be dependent on, again, do you machine, do you assemble, do you cast, are you in healthcare, are you in service? So there's a wide varieties there. Again, this is about the thinking and behavioral patterns. A little bit more about the manufacturing engineering role, and I've talked about some of this already, but it is critical and to be successful in that role. In turn, this kind of pulls you out of that daily improvement process, but by handing off a good process, you make that daily improvement Kaizen, as we like to do in the lean world, much better, much more effective for the folks you're handing that off to. And when you hand it off, it means it doesn't mean you leave them. You never really truly leave them, but hand it off from a daily standpoint that they take that over. So having a deep knowledge of the processes becomes important from the technical side, of course, but also, again, a strong relationship with the shop floor people, and obviously a strong relationship with the product engineering, and even to some degree, the marketing people as well. And obviously a deep comprehension of the one-piece flow and Jidoka, the aspects. So an example is this was another one of our design parameters that Kate evolved out of the one-piece flow was we wanted to design the line so a one-handed operator could actually run the line as effectively as a two-hand or two-arm person. So we want to design the line so literally the operator could run through the line, pick up the part, place it in the fixture would be ejected, he could pick up the part, he could start the machine and move on to the next process or machine with one hand. So that means our fixture design became important. If you're familiar with chaku, that concept became important. Safety protocols, physical safety protocols around the machine became important. One-touch start, so we had to meet safety standards. All those things became important for us to do that to allow a more stable line for the operator, because we wanted any operator anytime to be able to load and unload a machine within at least 5 seconds. repeatedly. So it had to be comfortable. We didn't want to have to hurry. We didn't want to have to fiddle around with doing it. And again, that's where the TWI becomes important to it too. Again, design parameters out of that. And so we designed the line or the system and the machine for the people. And also we were communicating with them. We just didn't design this line, dump it out on the floor, and let them have a go with it. Which leads me into a story I want to tell. So this is one of the lines I worked on. And I always say this, going through this process with these operators, I'll say Mike, Heidi, and Judy, which actually are pictured there. If you're looking at the slide there on the left-hand picture, you can see Heidi, you can see Mike in the background, and then picture to the right, you can see Judy. I would take these people anywhere in a line, and I would have every confidence where we could compete against anybody in the world between them and then what we do at the process. So we're really building this line when we built it for them, and we wanted to work for them. So a couple stories with it is Heidi, the little gal there in the left-hand side in a dark shirt, she was very quiet and all that. And I remember talking with one of the setup men, he was complaining about whenever he talked to Heidi, she would never do this on her own, but if you go ask her how it was going, boy, she would give you an earful. Very quietly and very politely, but she would give you an earful about the problems. And I remember one of the setup guys coming up to me and saying that. He said, I kind of hate talking to Heidi because she gives nicely, but she gives me an earful. And I said, well, Heidi does it to me too. But in this case, I said, Larry, but I've never had Heidi tell me something that wasn't true. So she never said anything that wasn't true. Yeah, a lot of problems, but everything was always true. So she's a good source to know and understand problems. I know it's also difficult because it gives you a whole laundry list of things to take care of, but it's a good source of that. And also, too, one thing with all the people on this line leading up to it, because they worked in the traditional department before we went into these flow cells or one-piece flow. They'd never worked in one-piece flow. We talked with them for months leading up to it, showed them layouts. You could kind of see our standard worksheet. We showed them those layouts, had them posted the line, talked to them about it for months leading up to it. And I told them as we were leading up to it, I said, when we physically put this line in place, because we were going to do it over Christmas when they were off, just because we needed that time, when you come back, the line's going to feel very tight, but it's going to grow. It's going to expand. Yeah, they get it. Okay, fine. So when they came back after Christmas break and physically walked up the line and saw it, they literally wigged out. Oh my God, Jim, how do we move up here? This is so freaking tight. Even though I'd been telling them that for months leading up to it, it's going to feel tight. It's going to feel very claustrophobic, but it'll move. Well, then they're asking me, what do you mean it's going to move? And I just said, trust me, it's going to move. Well, they kind of trusted me, not total, but partially trusted me. But what I meant by that, as they get up there and start operating it, it's physically not going to move and spread out. It's not going to do that, but they're going to get used to it. We're going to solve problems. It's going to feel more comfortable to them. And that's what it did. Now when I talked to them about it, say, so you feel comfortable? Weeks later, a couple months later, as we worked on things, they'd say, yeah, I get what you mean now, Jim. It's more comfortable. It certainly doesn't feel like that first day we walked up here, but it's still just as close together as it was before. But that was important. That in communication was important. It also gave me good feedback because they trusted me through this process. But that's part of that interface with the operators and so forth leading up to it. Just trying to communicate. And even with all the communication, the pictures, talking to them about it, it was still a shock for them when they first got in there. That's certainly not unusual. So I want to tell a couple stories about, because I know the title of this, I have nothing, what I call it, nothing new is needed to a certain degree. Because if you look at all this I'm talking about, again, it's really just changing patterns of behavior and the way you think about things. Nothing new as far as technology and things like that overarchingly. But I want to tell a couple stories from that standpoint. And this one, in this case, is a die-cast story. So at the company I was at, we die-cast well too. So we had all these big die-cast machines. Well, if you're familiar with die-casting, all these machines are huge. They're expensive. This is go back 20, 25 years ago. They're probably more now. These things were $1 million+ a pop. So they were not cheap machines, and they were big. They had big dies. So we did a lot of quick changeover processes with them. But of course, we had to batch with them. We had to build up all the castings. We had to keep them. We had to sort them, keep them before they go into machining. Well, in the cause of one-piece flow, ideally, I would like to see the die-cast process right into machining line. But just due to the size of the machine, the complexity of the machine, the cost of the machine, we obviously couldn't buy a die-cast machine for each machining line when we were machining aluminum in this case. So I went through a whole investigation process, and just, I guess, to keep this down short, but going through, I went to a die-cast machine, so big North American die-cast machines show, and went around and asked all of the North American machine tool builders, die-cast machine builders, the Europeans, because they were there, and even the Asian die-cast machine builders, and asked them about, do you have machines like this? This, what I called right sizes, smaller machines. None of them did. One went, oh, years and years ago, I think we used to make something like that. And then finally, one place said, no, we don't make anything like that. But I think there's a vendor that makes a machine like you're describing. And they told me where it was in this. It was in a big convention center complex. And I walked by there, didn't see it. I'll go back and look. So I walked back there, and in this little booth, I found this little tiny die-cast machine. And the interesting thing about it is, this machine was small enough, it had all these parameters that you could use. You could integrate it right into a machining line because it was very small, very small. It's about, you see the picture there, it's really about this, not much bigger than actually an office desk. So what does that mean? Well, that means the cost of it at that time was about 1/10. So 1/10, the capital expenditure. Also, that means the tooling is going to be less because you've got a much smaller die that goes into it. So the tooling is going to be less. The changeover need, instead of climbing up on this machine, needing some big crane and all the complication with it, the die is much smaller. It's actually right at a person's height. So all these parameters around you need to, for a one-piece flow, for a less capital cost, for if you want to do a Kaizen line, moving it around, it becomes much easier. Moving those die-cast machines were very expensive and difficult. So all these parameters were in play. So my point with this is no new technology was needed. These things existed. It's just nobody was using them in this different type of context. That's that different thinking, that different pattern of behavior. Didn't need to come up with new technology. It existed. So that's one story. Another one we had was same thing, shot blasting. We did a lot of shot blasting. All our shot blasting was done, same thing with those die-cast machines, was done in batch. Our shot blasting was done in batch. So you had a separate department that did shot blasting. You had to buy these more expensive machines. Again, a little bit of investigation. And lo and behold, they have these tabletop size shot blasters, which again, we could integrate those right into the line and with one-piece flow. And again, I think the capital outlay here was probably 5 or 10% of what these bigger machines were, plus no work in process, plus no separate department, plus it could be integrated right in the line. So all these parameters, again, no new technology, it already existed, it just was never thought of in that manner. And then the last kind of story I'll tell was, because actually the company I worked at, we actually had our own foundry. So big foundry, multi-million-dollar complex, and this just became something of mine. I always thought, well, why couldn't you make a scaled-down version of a foundry? There's a lot of parameters that go with this. What's the size of the component that you're actually casting, whether it's die cast, whether you're pouring in a foundry casting standpoint. So there's certain other real-life parameters you certainly have to deal with, and you may need it. If you're pouring big engine blocks, you just simply may need a big system. There's those real-life parameters. But in my company, our products, our aluminum product, or our cast iron products were much smaller. So when we did this pouring, the castings were a batch. There's multiple casts. And I was able to go and find a company that was actually using a very small foundry system. And what I found out from them, these systems were designed for colleges or universities that want to do training with a foundry, so they have this little foundry system. But they just took fundamentally what the foundry manufacturers did and scaled it down because they had smaller purposes too. They didn't do it for a lean reason. They really did it from a capital outlay because this thing was substantially less capital outlay. And the material they were pouring was very critical material for the type of product they meant, and they really wanted to pull that in-house. So this was their way to pull it in-house, keep their capital outlay down. But again, it's an example of there was no new technology needed. It was just thinking about existing technology differently. So with that, just some stories. I want to, kind of go into my, I guess, conclusion here about this. So you see up there, lean product and process development. So again, the product is always important. The product should always go in conjunction with us, but we're talking about the process development. Again, understanding, defining, and these different roles. The division of labor is important. Like manufacturing engineers, that you should be doing this thinking ahead, be proactive, think about doing the processing differently. That's kind of division of labor, doing that, having that knowledge, developing that experience. At the same time, you're fully interacting with product engineers, you're fully interacting with the shop floor and the importance of that. Again, I emphasize this, it's about this different, I have, in there, kata behavior, really TWI should be a part of that, because a lot of the kata behavior and questioning came out of TWI as it developed in Toyota, that different thinking and behavior, to the point where you want to get it to where you really want it to become this natural process that you're constantly going through with, really without thinking about it. Ideally, necessarily without pulling out the card to go through the process. You're going through that from a natural standpoint, and have the confidence to do it. And then again, I want to emphasize this point, that one last bullet, leverage the process part of the LPPD, because generally speaking, what they say is once you go through the product and process design standpoint and release it out on the floor, 85% of the costs are embedded and done. So not that the Kaizen workshops, continuous improvement isn't important, it is, but you really, again, depending on the circumstances, really only impacting 15% of your costs. So this is why this product and process development becomes so important, because this is the time when you can impact 85% of your cost. And that makes a huge difference rolling down the road. The 15%, the continuous improvement, is important because it gives you that intimate knowledge of your process that you can pull back and utilize in this 85% when you do the process development. So I can't emphasize how important this is. And as great as the Kaizen workshop is, all the Kaizen workshops in the world are not going to impact that 85% once you've spent the capital, once you've released this out into the shop floor or whatever your particular environment is. That's why lean process development is so critical. And again, back to this diagram. I'm going through this process, getting the experience. So where you want to get to is where this unclear territory is, you exist in it, but you want to get to where you just not exist in it, you thrive in it. You know the process, you trust the process, you just run with the process, and you can make great inroads in here. And actually, it's actually quite enjoyable and quite exciting to be in that. And ultimately, what this is, if you go through the process, the improvement, I have two PDs there, process or product process, you get to where you need to get to go. So utilizing that process, it'll take you, even when you don't always necessarily know the end game, you may have a target condition, as we like to use now, but it'll get you there. And the more times you do this, the better you get at it, and you build up that experience, which kind of think goes into my last slide here, back to that diagram, is you build up this ability of what I call speed and magnitude. So you can get from that current condition to the target condition quicker. And not only can you do it quicker, you bring a lot more knowledge and experience with you, and you could develop a lot more knowledge and experience as you go along the way quicker. That speed and magnitude of doing this. And if you can get to that point, not just as a manufacturing engineer, you want to get that in a product development, you want to get that on your shop floor from the daily improvement. When you get to that point, it gets you to a place where competition, you won't have any competition because of the speed and magnitude ability that you have. So with that, I'll leave you now. And I thank you for your time and hope you get some lessons out of it. And there's my contact information. If you watch this and have any questions, certainly feel free to reach out to me. And thank you very much.